Welcome back. Well, now that I'm in a way about stepping motors, I decided to also build an access control by an Arduino. Again, I bought these Chinese clones of Arduinos. They're not AVR, they're not Atmel uh, microcontrollers, but the Chinese clone version of it, right? They're cheaper, and you can get them eBay or Temu or Alibaba. I don't know. I got them from eBay. They're slightly different hardware, so you need to install the hardware descriptor in the Arduino folder, but they work just the same. Except for that they got more analog channels, and the pins are labeled as D. They have a D prefix before the number pin. And again, I got a TB66600 separate driver that I've used in previous videos. And this older dash jet printer that I attached a NEMA 23 motor to it, and I glue a limit switch to it as a home switch. And down below there's a 24-volt power supply. So the Arduino script, I just looked for a library and found this library on the Arduino IDE, which I'm using. So here I'm just describing the pins, the enable, direction, and pulse. Like I said, in this Arduino clone, the pins are labeled D with a prefix and then the pin number. The RPMs, the max RPMs of the motor, and the pulse per revolution. So this motor has 1.8 degrees per pulse, thus give you 200 pulses per revolution. The stroke here, it's 1000 pulses, so that's what I limit the torque to. The home switch is connected to pin number D9, D2, sorry, and like here table says, D8, it's the enable, D7 direction, and D6 the pulse. Define some constants. Clockwise is 1, counterclockwise is 0, and is 0 off is 1. That's for the enable, because enable is inverse on these drives. I don't know why, but it is okay. So you have to like swap 0 or 1 and so on. So you create the instance of the MC stepper and WC stepper, and I create some unsigned integers, count and target position, set up the port, set up the NEMA 23 stepper control, create a Boolean for the home switch, and then just wait for signals to values to come to the serial port on the Arduino, and then parse for an integer. And then if the integer is greater or less, move clockwise or counterclockwise. And if you reach the home switch, just clear the count and make the count, the current position equals to the count. So very short script, a few lines. And again, I'm accompanying this with a C# front plate, because I mean, you got the serial monitor here, but I wanted to make my own C#, so there it is. Actually, I had to drag it from this other monitor here. So let me just minimize this. Again, like in the previous videos, I wrote the C# form, so it will search for the port and connect to and show you which port is. So we already found the Arduino on COM port 10. You don't have to like drop down and search for it. What you do is connect to it. I connect to it, and then if you want to home the access, you just type 1 and then move. And you can see I got an LED attached to the home switch. The home switch also has a pull down resistor, so the input is always false until it's pulled up when the switch closes. So the switch is normally open, so when it's made, it closes and thus pulls the input up to 5 volts. Again, you can move this and you read back the value. So in the script, once I reach the target position, I echo back the target. So if you write 1, once it reaches the position, it will tell you I'm at 1. So that's what I'm doing here on the C#. And I also added a little an icon. So when you minimize it, the icon, it's a little stepper motor. And this time I added the upper part of the window banner, so you can drag it. In my previous video, I removed it. Probably I wouldn't add it back anyway. So let's move to 500, 550, 450, 50, 1000. And this is just one axis. I mean, you can have multiple axis control with it. I have yet to test and see how many axes can I add. Of course, the Arduino is limited. You cannot add many axes because I think it goes up to 12 D13. I'm already using 4 pins, so probably can add another axis to it. But that's pretty much with this Arduino. Maybe you need to go to a Mega. Like the 3D printers, they use a Mega Arduino board to control them. Some of them do. Other ones have dedicated controllers in them. But that one and that one over there, they use an Arduino Mega and have the Merlin firmware in them. So anyway, this is how I tested this system. Little Arduino clone that I've used in many of my projects, and the Generous TV62600 stepper driver, a generic NEMA 23 stepper motor, and just any axis. This one is bell driven. I got a bell screw one that I bought from eBay for my Siemens S7 1200 project there with it. Actually, this was much easier than the Siemens one because that's the way this thing rolls. I mean, the Siemens have, of course, a ramp, acceleration, and then decelerates, and then goes nicely. And when it homes, it goes slow feed rate, and then it slows down, reaches the limit switch, and then goes back and zeroes itself, which is far more sophisticated than this. But you can well do some access control with an Arduino, just like that. Not much more is needed. There you go. Thank you for watching.